Okay, so here we go. So in math, if I start telling you you have part of something, there's three math inventions that can measure when you got part of something, part of a cake, part of a whatever, that you're cutting it all up and you get some of it. What's one math tool we can use to measure when we got part of something, to measure how much we got?
Fraction.
A fraction. Okay, so we've done a lot of stuff this year with fractions. We're going to continue to see fractions this week some, but fractions aren't going to be the main name of the game this week at all. There's another thing we can use when you got part of something. Decimals. We have seen a lot of decimals. Decimals is the main name of the game today still, but probably not the main name of the game for the next week or two. We're going to transition eventually to a third thing, which won't appear today, but it's coming. We haven't seen this yet this year in a lesson, but you've seen it almost every day.
I'm guessing it's on the board. Drawings.
No.
Percentage?
Percentages you deal with almost every day just in life naturally. How do you deal with percentages naturally in your school life?
Like your phone percentage?
Could be your phone percentage, yeah, for some of you. I was thinking another thing, but yeah, for some of you, your phone percentage is more important than this other thing.
Your grade.
Your grade percentages is what I was thinking, but yeah, phone percentages probably in 2023 has passed by people's interest in their grade percentages. But percentages are coming. Fractions, how do you know how much you got with a fraction? What gives you the details about?
So the top number is how many pieces you have, and then the bottom number is like how many pieces there are.
Correct. What's that bottom number called?
Denominator.
Okay, so I'd say for fractions, the name of the game, number one, would be the denominator tells you how much you had in all possible. Decimals, what tells you what's the most possible in decimal world? See a decimal, how do you know whether that's like a great value or not much of a value? What's going on with decimals? Yeah, it's a P word.
Place value.
Place value. Decimals, the most important thing about a decimal is its place. So if we go right after the decimal, what place is that? That is the tens place. If we go one more place over, what's that one? Hundredths place. One more place over is the thousandths place. And that's where the most frequent three places by far are those three. What if I went 6 places over? What would that be? Not billions, if that's what you said.
The million.
It is the millions. What's a quick way to know that the 6th place over is the millionths place?
Just use normal.
10,000.
Yeah, I mean, you could count it through, but there's a quicker way to right away know that 6th place over is millions, boom. I could tell you 9th place over, billions, just boom, in 1 second, I know that.
You could add for the 3 spaces, add the 3 zeros.
It's the zeros, okay, so 10 has a 0, so the first place is tenths. 100 has 2, so that's the second place. 1,000 is 3, that's the third place. So when you get over to million, million has 6 zeros, millionth would be the 6th place over. Okay, but that's where we're headed this week. Some fractions still around, mainly decimals today. Today is decimal day. Percentages are common, we'll get into that another day. What are percentages always out of?
100.
100, that's common for another day. But today, they'll bring you in, they want all decimal answers. Every answer is going to be a decimal answer today. So if I show you this picture, and I want to know how much of that got shaded. Somebody have a decimal opinion on how much of that got shaded?
4 tenths.
Okay, so as a decimal?
4, wait, it would just be 4.
It would be 0.4. So what we have here, there's 10 boxes, so we use the tenths place, which is the first one, and I shaded 4, so 0.4. If I want to know who's not shaded, and I want to go decimal, no?
36.
0.6. Because again, we're still using the tenths place because there's 10 boxes. just use the first position. There's 6 unshaded squares, so go 0.6. Now, if there were 9 boxes, you can't do that today. We're gonna save that for another day. Why couldn't we do this if there were like 9 squares?
No, I don't know how to say this, but it's like, my brain turned off.
Okay.
There's no ninth
There's
place.
no 9th place, okay? If I had 6 boxes, there's no 6th place, okay? What we can do today is 10 boxes, we can do 10th place. If they wanted to be cruel, they could draw you something with 100 boxes and we could do it, but they're not gonna do that, okay? But they have to give you a place value today. Coming up future days, I might give you 4 boxes shaded out of 6, and we'll figure that out, but that's not today's job yet. Question about that first move? Middle move. Instead of giving you a picture, they're gonna give you a sentence. So they might say, what part of a meter is 14 centimeters? Well, again, it's all decimals today, so it has to have something to do with one of these places. There's something in this sentence that tells us whether it's tens, hundreds, thousands. Anybody have a thought on what are we working here? Tenths, hundredths, or thousandths places?
Thousands.
It is not the thousandths. It is the hundredths. Why is it the hundredths?
Because there's 2 digits.
Well, that is true, but if I go like this, it's still working the hundredths place, so it isn't that.
It's the centimeter is the like fraction of 1/100.
Yeah, centa is something that means hundred. So if I'm talking about centimeters, centigrams, centiliters, anything with centa, we'd use the hundredths place. So let me go back to the 14. If I go decimal and I want to use the hundredths place, where is that one?
Centi.
Where is the hundredths place?
Oh,
2 places to the right.
2 places. So if I've given you a 14, we would just go
14.
0.14. Let me change this to a 4. If it's 4 centimeters, I still have to use 2 places, because centa is in the hundredths club. What would it now be?
0.01.
No,
0.04.
it would be a 0.04. We need that 4 number to fit into the second position over. That would be 0.04. Can somebody give me another 100 kind of word?
Century.
Century. So if I went back and I told you this story but used the word century, it would be the same answer. I could ask you something like, what part of a century is 4 years? You'd give me that exact same answer back. Century would be the key word to tell you it's the hundredths place. If you hear any of these words and you think, uh-oh, I wouldn't know what place that would be, then take this note down. Because if you don't know what words mean what numbers, this is impossible. So if you don't know centa means 100, you don't know century means 100, jot that down somewhere. What's another 100 word?
Centipede.
Yeah, centipedes, they won't do any centipedes on this, but that would be 100 word.
I think it's like hecto.
Hecto? So if I went back to this story and I said, what part of a hectometer is 4 meters? The 4 would still go in the hundredths place because hecto would put us into the hundredths place. That's probably about it for now. How about millimeters?
1,000.
Is 1,000. So if I do anything with milli, this milli means thousandths place, so I need a decimal. Where's the thousandths place?
Treat.
3 over. So if I need to fill these 3 spaces, 12's the number I have to deal with. What's that going to look like? How am I going to get the 12 but fill up all 3 of those slots?
0.
We're going to go leading zeros as much as we have. And then 0, 1, 2. Other than milli, what's another word I could use and change the sentence but it would get the same answer?
Kilo.
Kilo. So if I came along and said, what part of a kilometer is 12 meters, we'd go same answer.
Millennium.
A millennium is 1,000 years. So if I came along and said, what part of a millennium is 12 years, we'd go same answer. I didn't do any questions with tens, but if I wanted to do tens, what would be another way I could do tens? I could go deca. So if I wanted to reproduce this answer, I could say what part of a meter is what part of a decameter is 4 meters? That would do that answer. What's another 10 word?
Decade.
Decades. So if I said to you, what part of a decade is 4 years? That's the answer. It's another one. Deci. If I said, what part of a meter is 4 decimeters? You would do something like that. There's one more in this category, there's one more in this category. It just came back to me. Think about tens. Think about your pockets or purses.
Dime.
Dimes. So if I'd say to you something like, what part of a dime, we use the tens place, is 4 pennies? You'd go 0.4. What can we do in the world 100? Dollars. So if I go back to this question, I could say to you something like, what part of a dollar is 4 cents? You would do that same thing. But if any of those words are surprising to you, jot those down, okay? Because in the homework, there's a few of these problems where they're going to use one of these words. The word's going to tell you what place to use, and you just copy the number in the right place. Question about doing that? You ready to rotate me?
Oh.
So we just need to catch from here to here to there. Are we good? Can we see the 31 and we can see the 1.2?
Yeah.
Got it all? Okay. So the third decimal game we're going to play today is comparing. So if we go to compare these, who wins, the 2 or the 5? The 2. Seems weird that 2 beats 5. Why does 2 beat 5?
The 2 is closer to being 1 than the 5 is.
Yeah, really 2's not competing with 5. Who's 2 competing with? 0. Okay, we need to compare these place by place by place. So here, 2 beats 0. 5 doesn't even get to play. So this is not 31 competing against 31. You start each place at a time. Who's the champ? The 31 without the 0, because what's the real competition? It's not 31 versus 31, it's who versus who. Who beat who? 3 beat 0. 3 beat 0, and no one else even got to play. How about this one? This is not 12 versus 12.
This one.
Why does that one win even faster than any? It has a whole number. Anybody with a whole number beats anybody without one. So we start with the whole numbers, and then you just go until they're different. What happens on this one if you go place, 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 and we're looking for them to be different?
They're equal.
They're equal. There's never a difference. We start, and it's 3 versus 3, 4 versus 4, 5 versus 5, 0 versus empty space. That's just a straight up tie. Question about the compare game? Okay, the almost last thing, and one more thing coming. The almost last thing they have you do is put them in order from least to greatest. I didn't write out least to greatest, I just put L to G. But they want the lowest number first, the greatest number last. It's kind of like a triple compare. So we look at the list of numbers, and you could either spot who's lowest and put them first, or you could spot who's biggest and put them last. It doesn't really matter. But we need littlest first, biggest last. So does anybody have an opinion on either who's the littlest or who's the biggest? 19 is the littlest. I would agree, personally, I'd have started with that one. Since this starts with a 1, that's the littlest one. Put that first. Then out of these two, who's the bigger of those two? The 21. The 21 is bigger because they both start with 2's, but that has some extra stuff. So then the middle number is the 2. So that's group of 3. Somebody jump in, either tell me who's the littlest one or who's the biggest one. What do you think?
2.01 is the biggest.
2.01 is the biggest, and I personally would have started with that too. There's no right or wrong way to do this, but that has a whole number, so that's definitely the biggest one. And then out of these two, we'll stick with you, who's the littler one?
The 0.0.
The one that starts with the 0 is littler than the one that starts with a 2, so put that in the middle. So that's kind of like a triple compare question. But instead of doing greater lesses, you sort them.
I like this game.
Question about sorting up? Is that your favorite game so far?
No.
No? Out of these?
Oh, yeah.
I got it today. Yeah, I didn't mean like in your whole life. I
Oh.
just meant out of what we did today,
I
that's
like
your favorite.
Roblox.
Okay. The last thing they're gonna ask you to do is pick which number is closest to 1. So the video won't go great for this because I'm gonna go too high for us to see it. But we have a number line here, so if I wanna go super, super, super close to 1, can somebody give me a number that's like super close to 1? 2 is close. Can anybody get closer to 1 than a 2 on the number line?
0.9,
0.9 would be, where does that go?
right before.
Right before it. So as we go through here, as we progress from 0, if I want just a little tiny bit, what would this be? Like 0.1, then there'd be a 0.2, 0.3. When I get halfway, I'd be at, where am I halfway when I'm on that path? That'd be 0.5. So 0.9 would be a really, really, really close to 1 kind of number. Can anybody beat 0.9? Closer to 1 than 0.9.
2.
Well, other than 1 itself, something closer to 1 than 0.9.
0.9999999.
That would do it. Yeah, a 0.9999999, that would be the champ. Could we beat that?
Yeah.
Yeah, how?
You just gotta add more
Just
nines.
say more 9s.
0.999.
But that's the kind of number we're hunting. You know, if we find like a 0.7, 0.8, we're doing pretty well. 0.9 would beat it. A 0.99 would beat that. That would be a close to 1 kind of number. What if I went to this side? Who could I go on this side that's also a pretty close to 1?
1.1.
1.1. Because if we count down, we're like 1.9, 1.8. You know, if I got here, I'm like 1.1. That's pretty good. You can beat 1.1. How could you get closer to 1 than 1.1?
1.01.
1.01. What if we want to beat that?
1.000000000, etc. of 1.
That would work.
Zero, one.
And if somebody wanted to beat you, they could do it. They would just have to have more patience to say more
0.
zeros.
I
Okay?
have the patience.
If we found like a 1.2, 1.1, those are pretty good. 1.0 something would be even better. That's what we're hunting on this. We're trying to hunt things that are closest to 1 out of a list. So out of this list, which of these numbers is the best number that's closest to 1?
1.1 and 1.
Out of these 3.
Oh, out of those 3, 0.8.
0.8. These are closer to where?
4.
They're closer to 4. This is a little bit over 4. This is a little bit under 4. This is super close to 1, just a little bit under. That's the kind of number we're hunting. How about that one?
The next one?
Yeah.
So
Closest to 1.
4.7.
No, 4.7 would be pretty far down the line. 4.7 would be closer to 5 than anything.
Oh no, the 1.1.
1.1. 1.1 would be just a little bit past the 1. 2.3 is not terrible.
0.11.
Out of these two, 2.3 would win, but 2.3 is closer to 2. So 0.1, 0.2, 1.1, those are all pretty close. We're narrowing down a little bit, but one of these 3 is closer to 1, although they're all getting pretty close to 1. 1.1. These are between 0 and 1, but those are closer to 0. 0.9, 1.7, 1.8, those are all pretty close to 1. You know, these are a little bit beyond the 1. This fell a little bit short of 1. Who's the win?
0.9.
0.9, that's a super close to 1. These are a little farther down. Those are a little bit closer to
2.
2. 0.9, 0.8, 1.5. That's probably the closest competition we've had, but the champ would be 0.9. 0.9 barely beats out 0.8. 1.5, like right in the middle of the 1 and the 2. And then how about these? This is a pretty close race as well. 1.1 is the champ. 1.1 is just a smidge closer than 1.2. This one's the farthest away. 0.2, that's closer to 0. But that's the games that the homework is going to play for us today. Where we're headed for homework, there's a 166 A to H. To begin with, what 166 A to H is going to do is play the first two games. 166, they're going to draw you a little bit of pictures and one a decimal. Then they're going to do you some sentences where there's a word that gives you the tip about whether it's tenths, hundredths, or thousands place, whether it's milli, kilo, centa, millenniums, whatever it is, dimes, dollars. But there's a word in each sentence or a picture that tells you what place to use on 166. Then the main thing is to the back. To the back, we just did set Z, so they have to start over. So after set Z, there's a set AA. So they're going to go like AA, BB, CC, BD. So the double letter sets come after the single letter sets. The set AA is going to play the other three games. The first thing they'll do is compare for about 10 of them or so. Then they're going to have you sort them in order, and that's your favorite game of the day. There's about 10 of those. And then they're going to do 5 of these, who's closest to 1. But again, today, it's all decimal stuff, but as we go through the week, decimals, fractions, percentages, they're all going to fit together. And the next couple weeks, we're going to spend some time like turning decimals into fractions, and fractions into decimals, and decimals into percents. And, you know, if I give you this is 31%, or it's 31 over 100, or this, if you reduced it, could be a 20th, or it could be 5%. We're going to be like flip-flopping, interchanging all of those things over the next week. But again, today, everybody's a decimal. Question about any of that?